Well, I'm really thrilled to be here today for the 25th anniversary unveiling of Hubble's, what I hope you will all find spectacular anniversary image. And one of the reasons I'm thrilled to be here is because, with my fellow astronauts, once we service the telescope or launch the telescope, there's always a question, will it work? And you all know it works, and that's why we're here. Otherwise, we'd all be in exile in countries like Bolivia or elsewhere. So just happy to be here. NASA science and NASA at large, our mission is to innovate, explore, discover, and inspire. And there's no better characterization of that than the imagery and the science that comes from the Hubble Space Telescope. We would never be able to be here talking about Hubble 25 years after its spectacular launch if it wasn't for the innovative ideas and engineering that went into the tools, into the new scientific instruments. The reason why Hubble is making some great discoveries today is that we've been able to use the remarkable space shuttle to put new instruments in, to take advantage of new detectors. I see a lot of digital cameras out here. I see a lot of smartphones. The detectors in those cameras, the CCDs, the CMOS detectors, were developed by pushing the frontiers of astronomy, and specifically the Hubble Space Telescope. When we explore, we look out into the cosmos. And that's exactly what Hubble has done. It has shown us an amazing story of the history of the universe. It has literally unraveled the mysteries of the universe, especially with the new detectors and cameras that we put on this last mission. When we explore, we discover things. Hubble was designed to discover a few specific things. It was to determine how fast the universe was expanding, prove the existence of black holes, and look at where stars were forming and dying. Many of the discoveries, in fact, most of the discoveries from Hubble were things we never expected. Things like the origin of gamma ray bursts, the most energetic explosion in the universe, other than the origin of the universe itself. That every galaxy has a massive, supermassive black hole in its center, including our own.
Charlie Bolden is the person who piloted the shuttle Discovery, which was carrying the Hubble all the way up there into the fall. So Charlie Bolden will come back because he was speaking when he came in. He's the person who actually piloted the shuttle. The main thing about this is that you have to understand that science goes everywhere. Okay? Science is everywhere. You have seen and helped sort of assemble the various models which are out here. And with those models, the measurement is very, very important. Okay? You need mathematics for that. If those people who thought that all the maths is not doing that, because the mathematicians are going to correct as to whether the mathematicians say, well, that's hard to say. It's true that you get the math wrong, get everything wrong. And if you got it wrong by 4 microns, okay? Now, there is, I can't give you an example from my own head, but you yourself have got examples from your heads. Each human head can be between 7 and 13 microns. What's a micron? Sorry? The micron is 1 million.
Wow, yeah.
A micron is 1 millionth of a meter. So that's very tiny. And you're talking of 4 microns, which are just less than half the breadth of very fine human hair. For those with very coarse human hair, you're talking of 1/3 the width of that. That's how far out things were. And then that was corrected. And after his correction, one of the people who was on that was astronaut Catherine Thornton. And Catherine Thornton is now retired from NASA, and she teaches at Virginia University, and she's a professor of engineering there.
So some of you might want to do engineering, you can apply to Virginia, okay? But it's a long way off for you to apply there. You might wish to meet her. And if you do, have a chat with your parents, because we'll be doing a gig at Manchester International Airport, and she'll be flying in and giving a talk. That will be on the 6th of June, which is a Saturday, okay? There will be other astronauts there as well, you know, from one from, you know, an old timer from Apollo days, and then some folk from Skylab, you know, and 2 from the shuttle program. But for me, it's really good that we'll have someone, you know, from the Hubble program, okay? Right, having said that, I'm just sort of gonna check my time and see where we are. Oh dear, ha ha, ha ha. And one of the things which I'll ask you all is if you could please turn off your telephones at this moment, because the moment is about to be upon us. Okay? Can you turn up, please, sir?
Preparing for sending humans to Mars. Well, in the end, we came up with a really spectacular image. Hubble imaged it. It was even better than we thought. There's a team here that helps prepare these images from the Space Telescope Science Institute. Jennifer's going to tell you more about the science for that image. But I think you'll all find it really compelling. It's something that we do when we celebrate. And
is that 10 or 9?
Are you ready, Charlie?
Okay, I've got this side. You take that side.
Let's grab the virtual screen. Here we go. Let's pull.
Oh.
This is the exciting name of Westerlund 2, but this is a gaggle of young stars embedded in their star-forming cloud, watching fireworks in a star cluster of very bright young stars, celebrating Hubble's 25th anniversary. Now, the fact that it's taken thousands of years for the light to get to us just means that they planned really far in advance. But this spectacular image shows a cloud of dense gas and dust. The gas is collapsing, forming new stars. Jennifer will tell you much more about it. But this image is one that, you know, numerous times over we didn't get because of the struggles with the technical part of Hubble and struggles of people on the ground and the tens of thousands of people at NASA, at our NASA contractors, scientists, engineers, people who support our space shuttle mission, our NASA mission, our science mission, all coming together around a common purpose to try and understand how the universe works and where our place in the universe is. And this has had just extraordinary reach, not only into the scientific community, of course, and rewriting the science textbooks and our understanding, but into schools around America, and in fact, around the world. Hubble inspires the world. And with that, I'd like to invite Jennifer Weissman to come up. And she's the Hubble project scientist at the Goddard Space Flight Center to tell you a little bit more about the science in this wonderful image. Thank you very much.
And I may have to tap dance while she gets to the page that I turned away from on her iPad. So
okay, it's a little exercise in freewheeling. This is really an exciting week for astronomers and people who love astronomy all over the world, because as we celebrate Hubble's 25th anniversary, we're celebrating some of the forefront science and the forefront discoveries we've made about the universe through all those years, and hopefully for years to come. This is an example of one of these spectacular images that we can get with Hubble. The image that we're looking at is a giant cluster of stars in the GUM-29 interstellar cloud nebula in this region of the sky we call Carina. It's a very vigorous breeding ground for new stars. It's about 20,000 light years away from us as we look toward the center of our own galaxy. And the central cluster here is about 10 light years across. There's about 3,000 stars in that central cluster. And they're very young. This is a really new birthplace of stars. The cluster is only about 2 million years old, which in stellar terms is very young. and it contains some of the galaxy's hottest, brightest, and most massive stars that we know of. So it's a very vigorous star-forming region. What's great about Hubble's sharp resolution forming region, what's great about Hubble's sharp resolution is that we can differentiate star from star even in crowded regions like this cluster. So this helps us scientifically to be able to understand what kinds of stars are in this cluster, how they're different from one another, how the population may have formed in the first place. We can study the characteristics because of Hubble's light, and that gives us a lot of information. The visible light filters that we used in this image were from the advanced camera for surveys, and it's showing us light not only from stars, but also from this colorful emission and ionized gas surrounding the stars, that little moon shape. In these colors, the red is representing a lot of emission from hydrogen gas, blues and greens are coming from oxygen. All of this is telling us that those bright, vigorous stars in the core are having an impact on the surrounding gas around them. Both the light and the stellar winds coming off the stars are impacting that surrounding material, the surrounding clouds. They're chiseling into the light is ionizing the gas, which creates these spectacular colors. When astronomers see these lit up nebulae, we say, aha, that's a region of active star formation. And this region is truly very, very active. Also in this image, we have data from the infrared channel on the Wide Field Camera 3. This is the spectacular camera that was installed by astronauts, thank you very much, on this last servicing mission in 2009. And with the ability, we can actually see into some of the dusty veils that might have otherwise enshrouded some of the stars that we can actually see. So if you look around this picture, you'll see some reddish colored stars. Those are stars that might have been invisible were it not for the infrared capabilities of the Wide Field Camera 3. We can also see a whole lot of stars, both in the center and embedded in that surrounding gas. That embedded region of star formation is really important as well, because regions like this tell us that star formation is active and ongoing. The big massive stars form first. That's what's happening in that central cluster. But all that activity, all that radiation, the wind activity from those central stars is impacting the surrounding gas, and that actually incites subsequent star formation in those dense clouds. So as we peer into those clouds, we see evidence of younger stars still on their way to forming, kind of the subsequent wave of star formation. With future telescopes, in particular the James Webb Space Telescope, we'll be able to peer better into those dense dark clouds and see young protostars as they form. We're so excited about seeing the activity like this, and I think that's one thing that Hubble has revealed to us all along, is that our universe is active. It's not on in our own solar system. Star formation in regions like this all around our galaxy and other galaxies. And we also see activity going on in so many other galaxies. So we're very appreciative of Hubble this week, and I think this beautiful image is a wonderful example of the kinds of things we can study and learn with Hubble. And with that, I'd like to welcome Dr. Kathy Flanagan up to tell us a little bit about the broader context of the Hubble telescope.
The spectacular new Hubble image that we've unveiled is the result of science and engineering community that challenges itself to maximize the productivity of this flagship NASA mission. The crisp and multi-wavelength quality of this remarkable nebula underscores how far we've come since the launch in 1990. Hubble has become the most scientifically prolific telescope of our time, thanks to the courageous astronauts who serviced it and the expertise of Hubble support teams. It has been a privilege for the Space Telescope Science Institute to help enable the immense scientific return. In the past quarter century, Hubble has engaged a significant fraction of the worldwide astronomical community, producing nearly 13,000 refereed science papers. In fact, Hubble has inspired and energized a whole new generation of young and diverse astronomers. And the scientific users of Hubble come from everywhere. Anyone with a great scientific idea can get observing time on Hubble, and often we team up with our peers in Europe, Asia, Africa, Australia, and South America to identify cutting-edge science that keeps Hubble on the forefront of discovery. NASA, in partnership with the European Space Agency, has given the world this scientific treasure. Hubble's reach goes far beyond the scientific user community. In the 20 years Hubble has been operating, it has indeed been the people's telescope. Hubble images know no national, political, or ideological boundaries. They are a subtle reminder that we are a common species on a small planet. There are no language or cultural barriers to being awestruck by Hubble images. Hubble's discoveries and images have been transformative for the public's perception of the cosmos. The images have become a cultural icon, found on coffee cups, record albums, and even tattoos. Through the Institute's education program, Hubble has excited, engaged, inspired an entire generation of students across the country and around the world. Hubble posters adorn innumerable science classrooms. In fact, tomorrow, the Institute is hosting a coast-to-coast teach-in for students from elementary through high school. Students will learn some of Hubble's remarkable scientific achievements and explore some of the most evocative images ever made of the universe. Administrator Bolden will participate in this. At our institute, we are also working hard to expand our audience. These two-dimensional images are now being rendered in 3D format. We have, for example, as a companion release, a movie showing a fly-through of how scientifically, realistically, the elements of this image actually come together. In addition, we are working hard to bring our images to the visually impaired. We have interactive iBooks now and tactile images, and working to prepare 3D printing capability for Hubble images. Our Celebrate Hubble's silver anniversary is not really retrospective, however. Hubble is today at the peak of its performance with her most productive years ahead. Hubble will have powerful synergy with a new generation of large ground-based telescopes and the next great NASA astrophysics mission, the James Webb Space Telescope. In fact, the Hubble experience has laid the groundwork for the future of space astronomy. NASA was born to do great things. It is the agency that delivers dreams, enriching the whole world. What amazing wonders await us over the next 25 years, Aunt.
So before we take a few questions today, we have a very special video that we want to show that's going to show a 3D flyby through the image. John, if you'd like to come up and say a few words about it.
Thanks, Amber. Why don't you stay up? When we launched Hubble, we had no idea how amazing the images would be. I mean, truly, people really hadn't thought about it. When the first images came out, of course, they were spectacular, things like the Eagle Nebula creation. And those early images told us how truly beautiful the universe is and rich the fabric of the universe. Well, now we have high-def Hubble images with these new cameras. And combining that high definition, the way our human eyes see, with our scientific knowledge of what these objects actually are like in the universe, we're able to create 3D fly-throughs. And so if we can go ahead and start the movie.
Okay, it's entirely up to you now. You can either get rid of the shower caps or you can keep them. If you really get cold, it's the Hubble hat.
And actually, Hubble is in what we call low Earth orbit. It's about, 340 miles above the surface of the Earth in orbit. That's why astronauts can.
I'm gonna stand here. How are we doing? No, wait. And you can turn up.
You can't, you're not picking up sound. Right. Pretend.
Turn up in a Gordon Brown moment.
Right. Do you want to sort of shoot a few of me? How is that? Yep. And that there is the finger of God. And this here is it. I'm going to sort of do one without. Hmm? Yes. I need one without sorry, without could you do one in some position? It's only rock and roll. Right.
How are we doing with the cakes?
There you go.
Are we ready to up? Are we? How are we doing?
How many are they down?
Where are they up? You know me.
He's bringing them here. Is it lacking down there? They're going to bring them on the stage.
Yeah. Let's keep going.
This morning we didn't have enough glitter. So I was like rushing around trying to get glitter.
2, 1. Okay, last.
Talk the microphone.
We need to go. I want you to put the rubbish in your time to pass it along. Alright?